Hi everyone, I'm John from the training department, and today I'd like to discuss with you complaints for dryer not heating, and specifically we're going to be covering the electric dryer today. The problem with no heating on a dryer, whether it's a gas or electric, kind of boils down to the same principles, but there's different components that we'll be checking today. A couple of things we'll need today is we're going to use a VOM meter, and I've got an amp probe too. We'll show you what we can use the amp probe for as we go on through the training presentation. But the first thing you really want to do is verify a couple things with the consumer. Verify whether or not they're feeling any heat from the dryer or they're having problems with maybe longer drying times. No heat from the dryers can kind of send you one way. Complaints where long drying times can kind of send you in the other direction. Now for your own gratification, if you want to do a quick check on it when you get there after you've asked the customer a few questions, is let's basically see if the dryer can heat, and this will usually take you about a minute or less. So basically what we want to do is turn on the dryer, go ahead and select a high heat cycle. In this case we'll use the cotton normal, and then turn it on. So basically what we're going to do is run this dryer for about a minute. After about a minute, let's go ahead and stop it. We'll reach inside there, see if we feel any heat or not, and that'll give us an idea of where we want to go from there. Now if we feel heat inside this dryer, it might have verified what the customers were saying. I'm getting heat, but it doesn't seem like it's drying in the normal times that it usually did. It's just taking a lot longer to dry. So what we can do at this point is let's verify the condition of the vent. A real simple test, it's visual for the consumers, is just the paper towel trick. What you want to do is verify your lint filter is okay, make sure it's not clogged. Shine a flashlight down here, make sure a rag or a sock or something didn't get shoved down there, or sometimes dryer sheets might have worked its way around the blower wheel. And let's go ahead and we'll do a quick check on this thing. So what we'll do is, we don't need heat for this cycle, we'll turn on the dryer, we'll select an air dry cycle, and we're going to have to go ahead and hold the button in, and then we'll start the dryer. Now what we'll do is take the paper towel. A good vent is going to suck this paper towel in. A poorly vent that's clogged or blocked is going to push this away, and that can account for her long drying times. At this point, if you notice that you have a bad vent, you can disconnect the vent from the back and do the same test again in front of the customer and prove to her that, hey, the problem is in your vent. Now you can see that the paper towel is being sucked down towards that vent. She'll have to have somebody come down and professionally clean it. You can also walk her outside. You can show her where the vent terminates at. Maybe they've got a problem with the end cap on the outside. Maybe a bird has gotten in there, and that's something that'll have to be cleaned by either the customer or a company that does that. Now if you got a situation where you're not getting any heat, or she's telling you she gets heat on certain cycles but not other cycles, remember on this electric dryer we have two heating elements, and they're both about 2,700 watts. Now when the customer selects the cycles for high heat and medium high heat, we're going to actually turn on both of the heating elements, so we'll get a total of about 5,600 watts. But when they select some of the lower heating cycles, they only cycle the excuse me, the outer heating element. So we might have a situation where only one of the heating elements is working, and that's why it doesn't work on the low heat, because the low heating element might have been taken out for you. So at this point, before we go any farther for a no heat complaint, let's first verify whether or not we have the proper voltage to make this work. Especially on a brand new unit, you don't know who installed the electricity for this dryer. She might have switched over, or the consumer might have switched over from gas to electric. Maybe they had the neighbor come over, he's supposedly an electrician and he's going to hook this up. Maybe they ran the lines that are phased together, so we have the 110 to make the motor work on the dryer, but we don't have the 220 volts or the 208 volts, excuse me, or the 240 volts to make the heating elements work. So let's go ahead and verify whether or not we got the correct voltage. So let's go ahead and unplug this unit. And then we'll take our VOM meter, and let's get this set up so our cameraman can see this. Okay, the next thing we want to do is verify that the consumer has the proper voltage and is wired correctly to make the dryer run. Now if you did a run test on it, you know that the dryer was running and it wasn't heating we know one thing. We know we have a neutral there, and we know we have L1 there, because our dryer motor works off the one side of the line, so it's going to be on the 120 circuit. So let's go ahead and we'll unplug this. We can do this test right here at the outlet, or we can go in the back where the dryer is, and we can check it right at the terminal block. Either one will work. Doing it at the terminal block on the dryer would also verify to us that the cord was okay too. All right, so what we're going to do here is we're going to go across L1 and L2, and we're looking for, depending on what voltage they have, either 208 or 240. And then we're going to do each side of the line. So we're going to go to the neutral, and this one, the top one, is the ground. So we're going to go L1 to neutral, and we're going to go to L2 to neutral, and see if we have half of that voltage that we're looking for on either one of those lines. So let's go ahead and we'll set up our meter here. We'll set it for AC voltage. Let's see if I can get it in an angle where our camera guys can kind of pick this up for you. That look good right there? I want to kind of peek over my shoulder to make sure I'm getting a good connection in here. So let's check for the total voltage. So we're going to go across L1 and L2. And in this case, we're reading about 210 volts. So this is a 208, which I kind of knew. Up in Huntsville, we're running off 208 right here. So now I'm going to check each one of the sides of the line. So I'm going to go from L1 to neutral. And what I got is about 120. So I've got half of the line. And then I'm going to check the other side. I'm going to go L2 to neutral. And I should get a similar result when I check the other side of the line. So let's get a good connection in here. There we go. Got about 122 volts on this one. Okay. Now, when you want to cross this, if you want to cross L1 and L2, and you got 0 voltage, the next thing to check is from L1 to neutral. See if I've got 120 there. Because what it might tell you is if I've got 0 across here, and I got 120 from L1 to neutral, and 120 from L2 to neutral, what I've got here is I've got 120 volts, but both of those lines are phased together. I don't really have 220 at that point. That's why I'm not reading 220 across that line. And typically what happened is when the electrician, whoever they had come down here, or maybe the customer did it themselves, had them both on the same phase. So they were both on the same 110 line, and that's why your dryer motor worked okay, but your heating elements, which you required either 208 or 240, didn't work. So in a situation like that, they'll have to call an electrician to come down and actually go ahead and update that wiring. Now, if you check this thing, and I was reading 120 from L1 to neutral, but I didn't get anything from L2 to neutral, what might have happened is check the circuit breaker. Those circuit breakers are designed to be ganged together. So by that, what I mean is when one of them trips, it should trip off both of them. But you don't know what you're going to run across in some of these houses. It could be an old circuit breaker where only one of the sides has popped, the other side is just hanging in there, and that's why the dryer motor was working okay, but not the heating element. Or you can have a situation where they didn't gang the two fuses together. They've got one fuse here and they've got one fuse somewhere else, which is completely against code, and that one had blown, but the other one was still good. So in either case, when you have a problem where you have a problem with the wiring, that is not LG's problem. That is not a problem with the dryer. So just patiently explain the problem to the consumer. Tell her what she'll need is a qualified electrician to come down and straighten out that problem with her dryer. All right, let's get into some checks on this if our voltage is good. So what I've done is I removed the actual screws on the back of this, and I got my board just about ready for you so we don't have to waste a lot of time taking this apart. Now we can do this up here, or we can actually go down to the bottom, but I want to show you a couple checks you can actually do at your board. This is kind of convenient right over here. So I've got my dryer unplugged at this point, so what I'm going to do is I'm going to take this cover off over here. Now these two tap relays over here, we got tap relay black and we've got tap relay white. Those are the two relays for your two heaters. One of them is for heating element number 1, and the other one is for heating element number 2. Let's go ahead and let's do a resistance check on them. So what we'll do is if we go across the blue and the yellow wire here, we'll actually read both of those heating elements if they're good. Now each heating element could range anywhere in resistance anywhere from about 17 ohms to about 22 ohms. Now we've got two of them, so we're probably going to read somewhere close to around 40 ohms. So let's go ahead and we'll set this for ohms. Put this down. Okay, so now we're reading both of the heating elements together, and we got a combination of the 20 and 20, so it totals up to about 40 ohms on there. Now, if you wanted to check each individual one, and with this situation, you'd be able to also check one of your safeties on here. And you have two safeties on here. We have the high limit thermostat, and we also have the high limit safety. The safety is kind of your last line of defense. That's the one that when that fails, there's really nothing else to protect the consumer against the dryer overheating. So if we have a situation where the safety were to open, and we'll take this apart and we'll show you where the safety is located at on here. Our policy at LG is we want you to replace both of those thermostats. We want you to replace the high limit thermostat and also the safety thermostat on there too. So now these connections that I'm going to, they're not always going to be the same. Your dryer might be a little bit different. So what you want to do is you want to refer to the schematic that came with the dryer to make sure that we're at the right connections. So in this case, I'll be able to verify whether or not each one of the heating elements is okay, and I'll be able to also at this point check my safety thermostat. So what I'm going to do over here is I'm going to take one of my meter leads and I'm going to go right here. We call this yellow 3. And I'm going to use this white wire right here because this is a tap right off where that high limit thermostat is. So that's in series with the heating elements and my safety thermostat. So I'll be able to check the safety thermostat, and I'll also be able to check each one of these heating elements. Now I'm going to do them singled now. So let's do the outer one. Let's see what we get. We should get about a half of that, or somewhere about maybe 20 ohms. There we go. We got just about 20.5 ohms, pretty close to 20 ohms at this point. So that's one of the heating elements. Now, if that heating element were open, I would get infinite at this point. I'd have to replace both of them because they come as an assembly, but at least it would know where my problem's at, especially if the customer says I don't get any heating on any one of the settings, except maybe when I use the high or the medium high, I do get heat, but I don't get really enough of it because at that point we're only going to be energizing the inner one because the outer one isn't working. So let's go ahead and do the inner one now. So this one we're going to go to yellow and we're going to use the same spot. And we got very similar readings, just under about 20.5 ohms. So that verified to me two things. It verified that each one of my heating elements was okay. It also verified for me that my safety thermostat was okay. Let's go ahead and we'll take the front of this apart and we'll go ahead and show you where those thermostats are located. And we can actually do those resistance checks right from the bottom. All right, before we go down to the bottom, what I'm going to do over here is I have the board exposed, and I'm going to show you we can use an amp probe to verify whether or not those heating elements are working too. They should be pulling less than about 10 amps. So what we're going to do first is let's start out with a high heat cycle. We'll once again use the Continent normal cycle. And you'll see when we use the Continent normal cycle, we're going to actually energize both of these coils, the inner and the outer coil. And then I'm going to stop the machine and then we'll go to a lower setting like your delicate cycle. And you'll see that on that particular cycle, since it's less heat, what we will be doing is we'll only be energizing the outer coil. We won't be energizing the inner coil. So let's go ahead and we'll turn on our amp probe. And now we're going to select a Continental normal cycle. And then we'll start our dryer. We've had a loose connection on this thermistor. Let me see if I can fix that. There we go. That's the problem with working in a training environment. Sometimes things take a lot of abuse here. So there we go. We've got it fixed. You see, we're almost at 9. We're about 9 amps right now, and that's on our outer heating element. Okay. Now I'm going to switch this over. Let's go to the inner one. And pretty similar results. We're just under about 9 amps. Right now we're just over 9 amps, so you can see it just varies slightly a little bit, but we're about where we should be on either one. Now it's not important. You can go to either one of the wires. I can go to either the black or the yellow, or the black or the blue. Now what I'm going to do is let's turn this off. And let's go to a lower heat cycle now. So in this case, let's use delicates. Okay, we're set for delicates. Let's turn the machine on. All right, we're going to go to the outer element first. See, we're under 10 amps. We're about maybe 9.3 amps. Okay, let's verify the other one. Trying to get one wire in here. You see that one isn't turned on. We're only going to be using the outer element. So you can see the outer element gets the majority of the workload, while the inner one is only really being used for your higher heat settings on there. So that's why it's sometimes important to verify with the customer what particular cycles they might be experiencing problems with. Maybe they're just using a delicate or a low cycle all the time, and that's why they're not getting any heat from it. And then when you come, you set it for a cottons and normal cycle, and we do turn on both of those heating elements, so we're going to get some heat on that, but it doesn't particularly work correctly for the customer when they're using those lower heating cycles. All right, what we'll do at this point is I'm going to unplug the machine. I'm going to take it apart. We'll get the drum out of the way so we can actually show you what we're checking at down on the bottom. We're going to do some resistance checks down on the bottom. So I'll see you in a couple minutes.